Hi Ankit, how are you doing? Hello Niranjan, good evening to you as well. How are you guys doing? Alright guys, how have you been? I hope you practiced what I discussed yesterday and you're doing fine with the differentiations. Hi Niranjan, how are you? Also, can you quickly let me know if my volume is loud and clear? Just let me know quickly if I'm audible properly so that we can go ahead and start today's discussion. Hello Trillions, great. So guys, welcome to Unacademy JEE English. This is a brand new channel by Unacademy, which is India's largest online learning platform for IIT JEE. And here everything is taught to you completely in English, so that no student feels uncomfortable with the mixed languages. All right. Great, Niranjan. Thanks a lot for letting me know about that. So today is the second lecture of my basic maths in this series, which is aimed for 2022 aspirants, that is students who are currently in class 11th, who have just started their class 11th. All right. So before we get started, yes, Trillions, good to have you back. Hi, Kushal. Yes, good to see you here. So before we get started, let me introduce myself one more time. My name is Rohit Dixit. I've studied mechanical engineering at IIT Delhi. I have 7+ years of teaching experience, wherein I have taught at a lot of top names in the industry. All right. I myself was JEE rank 447. So yes, I have been in your shoes. I have been a worried student like you once, not knowing how my exams will go. So I think I can help you through this struggling period very well. And I've already coached many students to top ranks in IIT JEE, and let's hope I can do the same with you guys. All right. Good evening, Manish. How are you? That was in advanced trillions. My mains rank was 192. All right. That time we used to have different format of paper. We used to have IIT JEE screening and IIT JEE mains. IIT JEE screening was an objective paper, which is similar to your IIT JEE mains right now. And instead of advanced, we used to have IIT JEE mains that time, which is a subjective paper. All right. Yes, only one guru mantra. Be consistent and work hard. Be very regular at your lectures. Pay attention to your concepts. Make your fun. So strong fundamentals and a lot of practice. That is the only guru mantra that I have for you. All right. Hello Akash, how are you doing? Yeah, there is some problem with my net. I don't know. Let me see. Why is my net glitching like that? Let me just do a quick check. I think it should be getting better now. Is it any better now? Yeah, this should be better now. Yeah, there were some problems with my net, I think. Maybe I should reconnect my internet. Let's see. Okay. Yes, I know it was lagging a bit earlier. It should be better now. I've just reconnected my connection. All right. All right, should be good now though. Yeah, I know it was lagging earlier. Anyhow, so before we get started, let me tell you one more time about the Unacademy subscription and the benefits that this one has for you. Alright. Don't worry, it'll get better. So the Unacademy subscription comes with live classes. You get to interact with your educators. You have live polls and leaderboards. You have test series and analysis, and you have live doubt clearing sessions. Alright. So trust me, the last two, yes, I know. The last two are very good and they will give a huge boost to your JEE prep. Alright, last 2 points. So, and of course, above all, you get access to India's best educators with your Unacademy subscription. Alright, so not to forget about that. Next, how do you get this subscription? So, there are easy steps. Install this app. Now, once you've installed this app, go to the plus section, select your goal as IIT JEE, and click on get subscription. Alright, it's that easy. That'll be tomorrow. Mohammad Farhan. This will be the last class for basic maths. I think 2 classes should be good enough. Rest is on you guys. You need to practice. Alright. So once you've installed the app, you go to the plus section, you select your goal as IIT JEE, and you click on get subscription. Alright. Now when you're getting subscriptions, you will realize that the fees has been kept very reasonable. For a 24-month course, the fees comes out to be roughly around 1500 a month, which is 50 rupees a day, which is nothing. Alright, so here you're getting affordable quality education, and on top of that you can use my code RD Live to get your subscriptions, and you get an additional 10% off. So it gets more affordable than this also. Alright, so don't forget to join us on the Telegram app with the help of the link that is shown above. Hi Sushant, how are you? So again, let's get back to the topic of the day. And Mohammad Farhan, the Minty quiz will be tomorrow, and I think at 4 o'clock. Let's plan it at 4 o'clock. Tomorrow at 4 o'clock. All right. So tomorrow is Sunday. I'm not having a regular session. Okay, in next class, we will be discussing about kinematics. All right, we start our discussion with motion and how to analyze motion. So kinematics is the topic which we are starting next. Okay. And you will have your Menti quiz tomorrow at 4 o'clock. Yes. So I'll see you guys tomorrow, and we'll have a short quiz. And then tomorrow I'm also conducting a special session wherein I'll be discussing something very interesting. I'll be discussing some mysteries of inertial reference frames. I'll discuss that tomorrow, what that is, in case you guys don't know. And then I will tell you guys a bit about special relativity, special theory of relativity. All right. So we'll have a discussion about inertial frames and some of their very mystifying properties, and how exactly Einstein got the idea of his theory of special theory of relativity. All right. So tomorrow 4 o'clock, Niranjan, you have your Menti quiz at 4 o'clock tomorrow. All right. So I hope there is no more confusion regarding that. So why don't we get started with today's topic then? Oh, right. Okay, fine. Yes, I know a lot of you guys requested unit and dimensions. Fine. Monday, I will take up units and dimensions then. All right. That session will be tomorrow at 5:30. All right. The session on special relativity and inertial reference frames and their some of very mysterious properties, and what actually led Einstein into getting to his theory of special relativity. All right, that'll be discussed tomorrow at 5:30. That session will happen over the Unacademy app. All right, so you guys can log into your app. It's a free session for all. All right, so you guys can join me there for this free session tomorrow at 5:30. I think the schedule will be shared to you very quickly. All right. Time on Monday. No, we're not starting our next topic on Monday. You know that I take this series, 2022 series, on Thursdays, Fridays and Saturdays. All right. So next we'll talk about units and dimensions on Thursday, next Thursday. All right. Not before that, because I need to take up class 12 topics also. So anyways, let's go ahead with the topic of the day, calculus. Yesterday we did talk about differentiation. No, not on Monday. It'll be on Thursday, next Thursday. Monday I'll be taking up class 12 topics, electrostatics. I'm continuing with electrostatics. No problem, Niranjan. I'm here to help you guys only. So whatever you guys need. Alright. So anyways, so yesterday we discussed about differentiation and some basic trigonometric formulae and what differentiation was. So differentiation was a mathematical way of knowing the slope of any graph. Sorry. So what we were doing in differentiation, we were trying to break every graph into very, very small parts. And if you look at a very small part carefully, it appears to be a straight line. And straight lines slope is easy to calculate. In straight lines, they have this special property that their average slope is always equal to their instantaneous slope. All right. So if I take a part of a graph as a very, very small line, and if I can find the average slope of that line, then that will also be my instantaneous slope for all the points lying on that line. All right. Yes, thank you for making that clear, Mohammad Farhan. So that was the idea behind finding the derivatives, and we discussed that the average slope of any line can be calculated as delta y over delta x, and because we are taking a very, very small part of the graph, we are taking a small change in y and small change in x, and that is what is represented as dy and dx. So my slope is represented as dy over dx. We remembered that how some functions results can be used again and again, and that's why we need to memorize them. I hope you guys practiced it. Thank you so much, Odinson, with a name like Thor yourself. Yeah, that's most humbling. Coming from Thor himself. I thought Thor was the god. Anyhow, so let's just revisit what we discussed yesterday in differentiation. All right. So in differentiation, we are trying to find the slope of some part of the graph, and the idea is if you keep getting this point Q closer to P, the moment you arrive closer and closer, eventually this straight line joining P and Q will turn into a tangent, and the slope of this line will be nothing but the slope of the tangent. All right, so that was the idea. So if delta x tends to 0, then this guy is almost here, and this straight line, the straight line that you see joining P and Q, is reduced to this tangent. All right, and that is what dy by dx is telling you. Dy by dx is telling you. All right, I'm not God either. I admire him too. All right. So yes. So in any case, so that was the idea. We were trying to find the slope of this tangent because this will be used. Yes, I tried that, but trust me, there was a little problem with that also. My slides were not, all the color schemes here are with respect to a white background. So Manish, if you could reduce the brightness of your screen, maybe it would be easier for you. But I tried the black screen. The black screen, trust me, was not working out for my PPTs. All right, it was the color schemes were going haywire. Right, so that was the problem when I tried with the black screen. The colors are not properly visible. All right, so maybe it'll help if you can reduce the brightness of your screen a bit. All right. So let's see. So we discussed how to get some of the derivatives yesterday, and let's discuss some of the properties of derivatives now. So the first property, if you remember, we discussed this yesterday also, that d by dx of k times fx, where k is a constant, is k times d by dx of fx. Alright, so we can also write this as k times f dash x, alright, where k is a constant. So if this is a constant, any function multiplied by constant, if that is getting differentiated, then you can write the derivative as k times the derivative of the function. Alright, thank you. No, Odinson, I will try to keep my teaching also not less. I will try to cover everything, alright. So don't worry. Yes, I'm glad about that. I'm glad about that. All right. So next rule that you have for derivatives is if you have to take the derivative of a sum of two functions. All right. What happens then? Then the derivative of sum of two functions can be written as sum of the individual derivatives themselves. Now you have three rules for getting derivatives. Now pay close attention. All right. Let's hope even if this channel becomes more crowded, then also all the people are more civil. All right. Let's hope, and they are all trying to learn. So there are three rules when it comes to finding derivatives. One is called the product rule. So in product rule, what do you do? When you're finding the derivative of the product of two functions, so let's say fx times gx, the derivative is found as fx times g dash x, which means fx times the derivative of second function plus the derivative of first function times the second function. All right, let's see an example of this. All right. Thank you, Odinson. Yes. Thank you so much. Okay, then let's move forward. Let's take examples of all of these. All right. So yesterday we discussed that what is the derivative of x to the power n? It was n times x to the power n minus 1. So let's say I have to find today the derivative of dy dx of, let's say, 5x cube. So that falls under my first category, right? K times f of x. So what will the derivative be? The derivative would be 5 times the derivative of x cube. The derivative of x cube would be 3x times 3 minus 1. So it will be 15x square. All right. So that is where you can see I've used this property. All right. So of course, like this, you can have many functions. You can have, let's say, d by dx of, let's say, 5 sine x. Now, once you have something like this, you can write this as 5 times derivative of sine x. Derivative of sine x is cos x. So that will be your answer for derivative of 5 sine x. So that's the example. Yes, Niranjan, well done. So that's the example of your first kind of case, where a function is being multiplied by a constant. Then you get the derivative by keeping the constant aside and multiplying the constant with the derivative of the function. All right. Yes, well done, trillions. Now, similarly, let's move over to the next example. And let's take a case relating to the next example. The next thing that I told you was that if a function is defined as sum of two functions, then the derivative of such a function is defined as sum of the two derivatives. All right. So let's see how we can find such a thing. So let's say your y was defined as x cube plus 3 sine x plus 4 e to the power x. All right. So here my y is a function of, is represented as sum of three functions. It is a sum of x cube, 3 sine x, and 4 into e to the power x. So what will be my dy by dx? My dy by dx can easily be calculated by individually finding the derivatives and summing them up. So what is the derivative of this? The derivative of this will be 3x square plus the derivative of this. The derivative of this would be 3 times cos of x and plus the derivative of this, which will be 4 e to the power x again. Yes, Niranjan, very well done. Great. Well done. Yes, so everybody is getting a hang of it. That's good. That's good. It is 3x square, trillions. 3x square. Yes, yes, yes. All right. So that's your second thing. Now let's talk about the third one. The third one used the product rule. All right. So the product rule said that to find the derivative of a function which is a product of two functions, the derivative is written as the first function into derivative of the second function plus the derivative of the first function into derivative into the second function itself. So let's take an example. Let's see. So let's say your y is defined as x square times sine x. Alright, so y is defined as x square times sine x. Now how do we find dy by dx? So dy by dx would be, first I need to find this function into derivative of this function. So first I'm writing my fx becomes x square only, then into g dash x, right? The derivative of second function. So what is g dash x? Derivative of this, which becomes cos of x. Now as my second term, I have to write plus the derivative of first function. So derivative of first function x square is 2x. So it will be 2x times now the second function. So second function being sine x. So that is how you find the derivative of this function. This is one function multiplied by another. X square is being multiplied by sine x. So to find the derivative, what you do is you first take x square, keep it aside. You multiply it with the differentiation of sine x. Okay, so that's your first term plus for the second term. What you do is you find the derivative of the first function, that is x square, and you multiply it with the second function, that was sine x. All right. Yes, well done, trillions. All right, that's good. That's good. So all you guys are getting a hang of this. Great. Similarly, let's move to the third part of the problem. No, I'm just doing my own work. I'm just doing my own work. Trust me, the calculus which is used in mathematics is going to be way tougher than this. You will have very difficult problems for differentiation there. I'm just telling you the differentiation and the integration which is required for physics only, keeping it as simple as that. All right, trust me, he'll be making you solve way tougher problems. So let's talk about the third rule that we have. The third rule that we have is the quotient rule. In the quotient rule, if you have to find the derivative of fx over gx, how do you do that? So you have your function defined as one function over another function. All right. So how do you find this? You use this quotient rule. So dy dx of fx over gx is equal to f dash x gx minus fx times g dash x over gx whole square. All right. So let's take an example. So like the last one. So let's imagine what happens if my y was defined as x square over sine x. Alright, now how do I get the derivative of this? So dy over dx. So the first term, if you remember, was f dash x. So this is my fx. So this becomes my fx and this becomes my g of x. Alright, so I have to find f dash x. So what is f dash x? F dash x would be 2x. And what is g dash x? G dash x would be cos x. So how are we supposed to approach this? We find f dash x into gx. Alright, so f dash x into gx. So the term coming first would be 2x sine x. Alright, minus g dash x times fx. So g dash x times fx, that is x square times cos of x. Alright, so this is x, not theta. Over g of x whole square. So g of x being sine of x. So sine of x, sine square x. That is the derivative of this function. Alright, let's see the answers that you guys have written. So you wrote sine x 2x, alright, minus x square cos x, great, over sine square x. Very good, very well done. So all you guys are getting a hang of this. Very nice. So, but trust me, you will need a lot of practice with this so that you become very used to it. Okay. Now, finally, what you have is something called the chain rule. Suppose you have to find dy by dx of something, but you don't have a direct method of solving it. And you know how to solve dy over du. Then you find dy over dx as dy over du times du over dt, some other times dt over dx. So you make a chain. And if you realize if I'm multiplying these will get cut, and eventually you will be left with dy over dx only. Alright, so if you don't know the direct derivative of something, then you solve it like this. Let's take up an example. Let's take up a simple one first. Alright, so why don't we take up a simple example first regarding this. Okay, so let's try and find out the derivative of sine of x square. Alright, so suppose your y was given to you as sine of x square. Now you have a problem. What? You don't know how to calculate the sine of x square. Alright, you know if had it been sine x, then I would have calculated it. So what do you do here? You assume, you say let u equals x square. Alright. Now you can write your y equals sine of u. Now once you do that, All right. No, not really. This is sine of x square, guys. Not cos square. Cos square will not come, I think. Yeah. Oh, cos of x square into 2x. All right, all right, all right. Yes, yes, that is correct. That is correct. So that is what you do. You find dy over du. What is dy over du? Dy over du is nothing but cos of u. All right, from here you see what is du over dx. So du over dx is 2x. Now you needed to find dy over dy over dx. You can say that dy over dx would be nothing but dy over du times du over dx. So yes, you multiply both these, you get 2x cos of x square. That is correct. Rightly done. Okay. Alright, so everybody seems to be getting a hang of this. That is great. Very well done, guys. So these are three important rules and these will help me find a lot of derivatives. Alright. So why don't we start with a practice problem? So find the derivatives of the following functions. Alright, find the derivatives of the following functions. So let's give this a try. Let's see if what we have learned so far helps me solve this one. Alright, there are two functions. First function is given to you y equals 2x cubed minus 1 times sine x minus 8. The second function is given to you as y equals sine of 4x square plus 1. You'd find the derivatives of these functions. So let's see. Let's try and find the derivatives of these functions. Come on, Niranjan. Come on, trillions. I'm waiting for your answers. Okay, he says cos x minus 8. That doesn't seem right. And he says 6x square times sine x plus 2x cube minus 1 times cos x. Yes, you should put that 2x cube minus 1 in brackets, Pavan. How are you doing? Good to see you here. Pavan just put 2x cube minus 1 in brackets as well. Alright, so Pavan has got the right answer. Yes, that is the correct answer. So when you find the derivative of this is one function, this is another function, and this is a constant. So what will your dy by dx look like? So first you find the derivative of this, multiply it with this. So what is the derivative of this? Derivative of this would be 6x square. So 6x square and 1 will become 0. Alright, times sine x. And second go, for the second term, you will put this as 1 unit. So 2x cube minus 1 times the derivative of sine x, which is cos x. And of course, the derivative of 8 is 0. So this is all that you have as your answer. So this will be the answer for dy over dx. No problem. Well, let's see. No, Niranjan, you seem to be having some problems. Yes, look at Pavan's answer. Pavan has got the right answer. Alright. So this is nothing but fx times gx, right? So the derivative would be f dash x gx plus fx g dash x. That's alright, Trillions, no problem. Niranjan, take a look at your answer one more time. Okay, no problem, Manish. No problem. It's okay. At least you got to know what the right answer was and you figured whether you did it right or not. So don't worry about it. Just need to know what the answer is. No problem, Manish. Alright, so how about the next function? How about the next function? How about the derivative of next class? Okay, Pavan has given me an answer. Pavan says cos of 4x square plus 1 times 8x. Yes, that is correct. Okay. Yeah. That is correct. That is correct, Niranjan. Well done. Great, Manish. Good to know that. Yes, well done, guys. So you're getting a hang of this, which is very, very good. That makes my job easy when I discuss kinematics. So of course, your y was sine of 4x square plus 1. Now, in this case, we are going to use the chain rule. First, we'll find the derivative of this considering this as 1 unit, and then we will multiply the derivative of this with the derivative of everything inside this. So dy over dx here would be cos of 4x square plus 1, which is nothing but the derivative of this considering this 1 unit, and multiplying this with the derivative of whatever was inside the bracket. So the derivative of this, which is 8x. So that is the correct answer, guys. I think most of you guys got this right. Alright, so great. Now let's talk about the applications of derivatives. Alright. The first thing that you know is that it can be used to find the slope of any graph. That is the very obvious. Yes, this is chain rule. Yes, trillions. So the first obvious application was that we will be using dy by dx to find the slopes. Now, second thing is that you can comment on the nature of the graph, whether it's an increasing graph or a decreasing graph. So if dy by dx is greater than 0, that means the graph is increasing in that region. If it is less than 0, you can say the graph is decreasing instantaneously. And if dy by dx is 0, so instantaneously the value is 0 and the graph might be turning or may have become constant. Alright, so there are two possibilities here. The two possibilities here is either it has become constant, or the rate is 0 instantaneously, which will be, yes, maxima and minima conditions. Graph is turning. Graph is taking a turn from that point. Alright, it's taking a turn, either upwards or downwards. So next, that is what we are going to talk about when the graph turns. So derivatives can be used to find the maxima and minima points on the graph. What are maxima and minima points? The maximum values and the minimum values possible for the graph. So suppose you have a function, mathematical function, whose graph goes something like this. Let's say, so this is called a maxima point, this is called a minima point, this again a maxima, this again a minima, and so on. Alright. So these are called local. This is called a local maxima, by the way. And these might be called local minimas. This is local minima. Here you're only talking about a region. In a small region, this has the maximum value. In a small region, this has the minimum value. So these are called local maximas and local minimas. Yes, you seem to know your calculus trillions. However, suppose this is the highest point of the graph that it will ever attain. Suppose the graph never goes above this. In that case, this is called global minima or global maxima. So wherever you go, you can go anywhere. Nothing is higher than this. So this is called a global maxima. And similarly, you will have global minimas. So but at all these points, you will realize the graph is turning. It's taking a turn from the upward direction to downward direction. So you realize here, if you draw the tangent, and here if you draw the tangent, at all these places, when you draw a tangent, the slope of the tangent is becoming 0. So remember, at all the turning points of the graph, the slope of the tangent becomes 0. So you can use this condition. So you know for both the maxima and minima points, your dy by dx will be 0. Now how to differentiate? How to differentiate between the maxima or the minima, whether a certain point is maxima or minima? You find the d2y by dx2. What was d2y by dx2? d2y by dx2 was nothing but rate of change of the dy by dx. You realize at a maxima point what is happening? The slope was like this, it is getting reduced and then ultimately it is becoming negative. So what is happening to dy by dx? dy by dx is a reducing function, right? Its values are going down. So the slope is going on decreasing, it becomes 0, then it eventually becomes negative when a maxima is arising. So at the point of maxima, dy by dx goes from positive to 0 to negative. So dy by dx is decreasing constantly. If dy by dx is decreasing constantly, then you can say that your d2y by dx2 will be less than 0. Right? d2y by dx2 will tell you about whether the sign of this will tell you whether dy by dx is increasing or decreasing. Alright. Okay, so if your d2y by dx2 is negative, then that means the point that you found, you may have found multiple points, right? So let's say you found point 1 as an answer of this, point 2 and point 3. Let's say you found 3 points. So for any of these points, you will check what is the value of d2y by dx2. So for whatever points, the value of d2y by dx2 is negative, those will represent the maximum points. Similarly, whatever points which have d2y by dx2 as positive will represent the minima points. Alright, so remember this. Alright, why don't we take up a few examples? Alright, so let's take a random graph, let's say. So y equals 3x cubed minus 2x square plus x plus 5. So find all the maxima and minima points of this graph. So you have to find the maxima and minima points of this graph. Let's see about this application. So go ahead, give this problem a try. Alright, let's see if you can find the maxima and the minima points. So okay, he says 9x square minus 4x, where is plus 1? Where is plus 1? Trillions, you missed plus 1. We find the dy by dx. That's d2y by dx2. You are supposed to find the maxima and the minima points. Find maxima and the minima points for this graph. Alright, so how do you find maxima and minima points? At which points are they occurring? You'll have to solve that quadratic that you're getting. Alright, that is how you find the points of maximas and minimas. Yes, dy by dx for them must be 0, which gives you an equation for x. You have to solve that equation, get your roots, and those points will represent the maxima and minima. Alright, give this a try, guys. Give this a try. Okay, he says x equals 2 over 9. X equals 2 over 9. Okay. No. Not really. No. No, that is not what you're doing. Alright, so let's see how you solve this. No. So first you find dy by dx. First what you do is you find dy over dx. So what is your dy over dx? That is 9x square minus 4x plus 1. Alright. Now you say that for maxima and minima points, this should be equal to 0. Alright. So when this is 0, you get two values of x. You will get your x as 4 plus minus root of that is 16 minus imaginary roots. Okay, since I randomly selected the equation, I'm getting imaginary roots, which is weird. Alright. So roots are imaginary, which means this graph does not have any maxima or minima points. Alright. B square plus. Alright, so no worries. We can talk about another graph. Let's talk about a simpler graph. Let me not randomly take up graphs. How about a parabola? You already know the equation of a parabola as this. Alright. And you already know what the minima is going to be. And so let's talk about an equation like x square, 3x square plus 5. Alright. Let's talk about that. Let's talk about that first. Alright. So when you find the derivative, you find the derivative as 6x plus 5, or let's make it 3 for the sake of simplicity. So in this case, what do you realize when you solve this? Put this as 0, x equals minus 1. So which means that the maxima or the minima point will come at x equals minus 1. Alright. Yes, there was no, alright, great. So there is only one root. Now whether it is minima or maxima, you need to find d2y over dx2 as well. So d2y over dx2, that is 6, which is obviously positive. So if it is positive, this becomes minima. This is representing minima. And what is y minimum? So the minimum value of y can be calculated by posting x as minus 1. So it will become 3 plus 6, which is 9. So in this case, when you plot the graph of this, you will see your graph as always increasing, and it will have a minimum value at x equals minus 1. Alright. That is how you solve. The minima is at x equals minus 1, and the minimum value of y ever is going to be 9. Alright. Yes, there is no maxima in this case. You are correct about that, Philians. Because you are only getting one root. If you are only getting one root, and we realize that one root is representing the minima, so there is no maxima. Alright. Okay. So let's try one more problem. Determine where the function x plus 1 minus times x minus 2 whole square is increasing or decreasing. Alright, do this. Also find the maximum and minimum values of the function. So quickly solve this. I need to make an urgent call. Yes, we are getting to that. Don't worry. We will get to that very quick. Just 5 minutes. Try this problem. Let me come back and wait. Hello. 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 Yeah, Lisa, tell me. I'm calling you in the middle of my session. I have to give it's a break. That was meant for Sunday though. It was meant for tomorrow. Can I do it at the end of my session? My session ends in another by 7:30. Okay. Okay. Alright, I'll have to talk to Simran about this. Alright. Alright. Okay. Sure. Alright. Alright. Did you guys get your answers for this? Let's see. Sorry, I had to go away for 5 minutes. Something urgent had come up. Increasing from infinity to 0 again at 2 to infinity. Sorry guys, I had to attend to a very urgent matter. I'm back now, so let's see if you got your answers. Okay, so Pawan is giving me an answer. He says increasing from minus infinity to 0 and again after 2 and decreasing between 0 and understand. Okay, don't worry, no problem. So you have your fx, alright, you have your y as x plus 1 times x minus 2 whole square. Let's go through this. Alright, so what you need to do is you need to find your dy over dx. Alright, dy over dx. So your dy over dx can be found by using the product rule. So what is the derivative of this? Derivative of this will be 1. So the first term becomes x minus 2 whole square plus x plus 1 times derivative of this. Derivative of this would be into 2 times x minus 2. So that is what your dy by dx is coming as. So all you need to do is find the 0 points for this. So where all will the graph turn? So let's first find that. Alright. So if you put this to as 0, so let's see. For dy by dx equals 0, would you get your answers? You get your answers as x equals minus 1 comma 2. So you have 2 points wherein, alright, so sorry. So when you put this as, not this, when you put this as 0, what do you get? You get x minus 2, you can take this entire thing common, you get x minus 2 here, x minus 2 plus you have 2 times x minus x plus 1, alright. So this is equal to 0, that is what you're getting, right? So what do you get? X minus 2 times, this becomes 3x and plus 0, okay. Alright, just look at this. So this is what you're getting. So the two roots that you're getting is x equals 0 and 2. So when you put your dy by dx as 0, you're getting two answers of 0 and 2, which means the graph is turning twice. The graph is turning twice. Alright. add 0 and add 2. Now all you need to do is find out I'm just differentiating it. Okay, good. So these are the two points that I got to know where the graph turns. Let's see if these are maxima points or minima points, and which one are the maxima points and which one are the minima points. So for that, what do I need to do? I need to differentiate this also. Alright, so when you differentiate this, you find your d2y by dx2. Let's see what you're getting that as. So that will be 2 times x minus 2, alright, plus 2 times x minus 2 plus 2 times x plus 1. So that will be the double derivative of this function. Alright, you will have these three terms. You differentiate dy by dx one more time, you get your d2y by dx2 as this. Alright, for the first function it is simple, it is 2 times x minus 2. For the second function, you are again applying the product rule. Product rule means you're differentiating x plus 1, which is getting to be 1 times 2 times x minus 2. Then 2 times x plus 1 is multiplied by differentiation of x minus 2, which is again 1. So you're getting this as your d2y by dx2. Let's check it for x equals 0. So for x equals 0, let's see what value are you getting. If you put x 0 here, you're getting minus 4. Alright, then here you're getting minus 4 again, so minus 4 again, and then plus 2. So you are getting minus 6. So since it is negative, what does that mean? It means that this is maxima. So this is your maxima. Alright, why? Because you're getting a negative value of d2y over dx2. Now, let's check about x equals 2. So for x equals 2, let's see what you get your d2y by dx2 as. So d2y by dx2 is, if you substitute it 2 here, this becomes 0, this also becomes 0, this becomes 3, so you get plus 6. So since you're getting plus, so you know this is minima. Alright, so what does that mean? How does the graph go? The graph probably is going in such a manner that this is maxima, and then it is minima, and then like this. So this is 0. 0 you have a maxima, 2 you have a minima. That is how you can conclude about this graph. Alright. I hope you can see this. The graph should go something like this. It would form a maxima here, turn once here at x equals 0, then turn again at x equals 2. You're getting a maxima here and you're getting a minima here. Right. So you see the graph was increasing from minus infinity to 0. So the graph increases from minus infinity to 0. Alright. Now it decreases from 0 to 2. Alright, and then it starts increasing again up to infinity. That is why you're getting two local minimas, one local minima and one local maxima, and you don't have any other turning points in the graph. The graph only turned twice. Once it turned downwards, then it turned upwards. Alright. Yes. Of course, there you have x, the second degree of x, there you have 1 degree of x. When you multiply, this will be a cubic equation, of course. Okay, even if it is at 4, yes, that means I'll just shift this axis. Alright, that is what it means. Fine, thank you for pointing that out, Pavan. I'll just change my x-axis. Alright, so my x-axis would be somewhere here. The point remains the same. Yes, absolutely correct. At x equals 0, I will notice that I'm getting my y as 4. So this will be y of 4. So this is what my graph will look like. Alright. And at x equals 2, I think I'll get it as 0. So this will be 0. Alright. But the main agenda was to see where the graphs are turning. So yes, it becomes 0 at 2. So this will be 2, this will be x equals 0. Alright, this is what your graph would seem like. Alright, so once you have a rough idea of the graph, you can tell me that it is increasing from minus infinity to 0, then it decreases from 0 to 2, and after 2 it starts increasing again. Alright, that's the idea. Alright, so I hope you guys figured out how to do this. Okay, let's move on then. So that is how you will decide in what regions is a graph increasing and in what regions is a graph decreasing. Alright, find the turning points and get your idea about the graphs. Alright, let's practice another problem. So determine where, if anywhere, the tangent to the line fx equals x cube minus 5x square plus x is parallel to the line 4x plus 23. Why don't you guys try this problem quickly? Try this quick. Quiz, I think we'll have a Menti quiz on YouTube. Alright. Satish, the schedule of classes that I'm holding here on YouTube will be available to you on the community page of the channel. So you can check it out there. But usually for Target 2022, I come online 3 times a week, Thursdays, Fridays and Saturdays at 6 o'clock. Alright, Satish? So that is my timings. So let's see if anybody solved this one. Determine if anywhere. Determine the points, that is if at all, the tangent to this function becomes parallel to the line. Alright. So let's see if you guys can solve this. We got 0, 10. X equals 0 and x equals 10. Alright, let's see. So let's see. If these two graphs are parallel, at the points that they are parallel, they must have the same slope, right? This guy has a slope of 4. So the slope of this graph is 4. So all I need to do is find all the points wherein this graph slope becomes 4. Alright. So I have my y as x cube minus 5x square plus x. Alright. So let's find my slope, dy over dx. So dy over dx is 3x square minus 10x plus 1. And what do I need this to be? I need this to be equal to 4. Whenever this is equal to 4, then this will be parallel to this line. Alright. So you're not supposed to find. I don't know, Satish. I only, you can check out the community pages, alright. So, let's solve this quadratic equation. When you solve this quadratic equation, what do you have? 3x square minus 10x minus 3 equals 0. Alright, so that's your equation that you're getting. Solve this quadratic. Alright, so I can write this as minus 9x minus x, or no, let's just x equals 10 plus minus 100 plus, and that's 36 over 6. Alright. Alright, so you can solve this and you find 2 points. So 10 plus minus root of 136 over 6. So at these 2 points, your given graph, yes, Manish, they are on Unacademy JEE. This is Unacademy JEE English. Alright, no problem. So these are the 2 points where your graph will become parallel to that straight line. Alright. Hope everybody followed. Oh, 4. What has been asked to you in this question? You've been asked to determine if anywhere the tangent line to this is parallel to this. Right? That is what you've been asked. So when will this graph, when will fx be parallel to the straight line? If the slopes are equal, right? So to be parallel to straight line, it must have the same slope at those points. Right? Have the same slope as the straight line. If the slope of the straight line and my graph or the tangent is the same, then they will be parallel, alright? What is the slope of this? This is a straight line, y equals mx plus c. This is m equals slope. We had talked about this yesterday. Trillions, we had talked about this yesterday. This equation is y equals mx plus c. This m is nothing but the slope. So what is the value of m in this problem? It is 4. Alright, what has been asked to you? What will be the points where the tangent to the graph will be parallel to that straight line? Alright. So is that clear now? Is it clear how I kept it equal to 4? That is why I am keeping my dy by dx equal to 4 here. Yes, you can do that as well. Yes, Niranjan is correct. You can do that as well. You can find the dy by dx of both the expressions and equate them. But for a straight line, you directly know. You don't need to differentiate, right? For a straight line, you directly know the slope. Okay, great. Alright, so okay, so why don't we skip this problem? You can try this problem later and I'll get started with integration. Alright. So, but you can note this problem, you can try this out later. So you've been asked that the position of any object is given by this. You have to find the velocity of the object, if the object ever stops, and when it is moving right and when it is moving left. So you just differentiate and find this. When it stops, you know v will be 0, and when it is moving right, when it is moving left, means when is v positive and when is v negative. That is what you have to find out. Hi Sumit, how are you? Alright, so you guys can try this problem later. I want to move on and start integration. Alright. So let's talk about integration now. Now that most of you guys, I hope everybody is feeling comfortable with differentiation. You just need a bit of more practice, alright? So watch this video again, watch the last video again and get some practice on your own, alright? And you should be comfortable with differentiation. Now let's talk about integration. So integration, as the word means, what does the word integrate mean? It'll be on YouTube. It won't be on YouTube actually, it will be on Mentimeter. Alright. No worries. So what does the word integrate means? Integrate means to add things up, right? That is what we are doing in integration. We are adding things up. Alright, so let's see what integration is. So in mathematics, every operation has an inverse operation. In the same way, differentiation also has an inverse operation which we call integration. Okay. The notation of integration is as follows. This is the symbol that you use to signify that I am integrating this. So this is known as, when you see this symbol, what do you call it? You say that this is the integration of fx with respect to dx, with respect to x. Alright. So this is integration of fx with respect to x. Now, what do you know about integration? Integration is done in two ways. Alright. So there are two methods of integrating functions. One is called definite integral, another is called indefinite integral. These two are represented as follows. So if you have simply this sign, this is the integration sign, and a function and a dx without any limits here, so this is called an indefinite integration. And if you have two numbers written here, this is called a definite integration. Alright. So you call this integration as the integration of fx from x equals a to x equals b. Alright. That's just the terminology. Get familiar with the terminology so that we can see the meaning of all this. What is the meaning of all this? A and B are some points that you chose. Alright. Some x equals a and some x equals b, between which you need to find the integration. So let's see why I'm doing that. Why I need two a and b. What is integration? Let's see it geometrically. Geometrically, integration of fx with respect to x between a and b represents the area under the graph as shown in the figure. So if I write this is nothing but this entire area. That is what this will give me mathematically. So if I have any graph, then the integral of this function from a to b will give me, I will draw fx. So this is the graph for fx. This is how my fx goes. Now integral of fx dx from a to b would give me the area under the graph between x equals a and x equals b. Let's see how that is happening. Alright. So in integration, let's talk about both first. Let's talk about integration indefinite and then definite we'll talk. And we'll figure out how we are getting the area on integrating. Alright. Okay, Niranjan, you can try that later. Pay attention on integration now. Okay. Pay attention to integration. And if you got the expression for velocity right, at t equals 0, I think the velocity is coming to 0. Alright, so that is one instant when it was at rest. So, yes, you can do that later. But let's try and understand what integrations are. Alright, let's try and understand first. Yes, you will. You can solve some basic problems. Not all. You don't need to try the difficult ones. Because trust me, integration can get very tricky. So first, let's understand what integration is. So integration without limits is known as indefinite integral. It is represented by the symbol integral of fx dx. It is also called anti-differentiation. Now, pay attention to this. Because it is reversing of the process of differentiation. Alright, so how do you find the integration of something? Suppose you have a function f. One can find the function capital F, which is the result of integration of f if f dash is x. F. Alright. So this might appear confusing right now, but let me tell you what I'm trying to say here. Suppose you have a function which is some y as f of x. Alright. So when I differentiate this, so let's say I get some z which is derivative of this. So when I differentiate fx, I get f dash x. Now when I integrate f dash x, I get fx. That is what I'm trying to say. That integration of f dash x dx would be f of x. So it is the opposite. It is the opposite of differentiation. Alright. I hope you guys followed this. That would, the aim is that this function will give the opposite of differentiation. If you differentiate fx and you get f dash x, then if you integrate f dash x, you will get fx. Yes. Yes, plus a constant. We will talk about that also. But that's the general idea behind integration. It is anti-differentiation. You can just remember that. It is anti-differentiation. You're doing the other thing. Alright. So instead of having set boundaries, one only finds the equation that will produce the integral due to differentiation without having to use the values to get a definite answer. So when you're performing indefinite integrals, you will find a function here. You will not get a value, you will find a function. And you always add a c to this, and this c is a constant. It is called constant of integration. So when you're making indefinite integral, you will find a value or a function of x. You will get an equation of x. You will not have a definite answer or a definite value like 2 or 3. No, you're getting an equation of x when you integrate. All right. So just remember, this is anti-differentiation. That's about it. Let's see some important results. So the integration of x to the power n is x to the power n plus 1 over n plus 1 plus c. Remember this. So let's see how. Let's try and differentiate this one. Let's see if I differentiate this, what do I get? What is the d over dx of this? So I already know how we would do that. We would keep n plus 1 here, then x to the power n plus 1 minus 1 over n plus 1. So you will realize that this gets cut, and what you get is x to the power n. So you realize if you differentiate this, if you differentiate x to the power of n plus 1 over n plus 1, you are getting x to the power n. So since your integration was anti-differentiation, you were trying to find the opposite. So you were trying to find the function which we would differentiate to get our function. So that is why the integration of this becomes this, and then you add a c. Alright, I hope everybody followed the logic. Similarly, the integration of a, where a is a constant, is ax plus c. Why? Because when you differentiate this, you get a. Alright. Similarly, integration of sine x will be minus of cos x plus c. Why? When you differentiate d by dx of minus cos x, what is that? What is d by dx of minus cos x? It will be minus times d by dx of cos x, and d by d of cos x, if you remember, was minus sine x. So minus times minus sine x, which is sine of x. So if you differentiate it minus cos of x, you would have gotten sine x. That is why once you integrate sine x, the integration of sine x will be minus cos x plus c. Similarly, the integration of cos x is sine x plus c, and integration of sec square x dx is tan x plus c. Integration of e to the power x is e to the power x, and integration of 1 over x would be ln x. You remember, when you differentiate ln x, you get 1 over x. So integration of 1 over x is ln x plus c. Just remember one thing, one more thing to be noted. This is true only for n not equal to 1. Alright, your n cannot be minus 1. Why? Because then what happens to your denominator? Your denominator here becomes 0. So this is only defined for, just remember this, that this is only for all n not equal to 1. When n is equal to minus 1, that is 1 over x, then you have a different rule. This is for basically n becoming minus 1. Alright. So this is how you find the integrations of different functions. And c here is known as the constant of integration. Alright. Yes, the denominator being 0 will be a problem. Alright. Now let's try some integrations. So integrate the following with respect to x. So what will be the integration of x cube? Let's try this. Let's try integrating these. ln is log to the base e. I don't know if you have studied log to the base e of x. This is also written as ln x. So ln is the short form, meaning it is log to the base e. Alright, that is what ln means. Yes, well done, trillions. This is x to the power 4 over 4. Very good. Correct. Yes, well done. Alright, let's move forward. Come on. So what will be the integration of this? Alright, for everybody who doesn't know what ln is log to the base e. E being Euler's constant. So what is the integration of this? The integration of this would be integration of this, which would be x square over 2 and minus ln x. Why? Because once you differentiate this, you will get this. Alright, integration of this gives you this, differentiation of this should give you this. Alright, similarly, how about this? Let's talk about part 3. Part 3, the answer would be e to the power x, and this is x to the power minus 2, right? So x to the power minus 2, integration of x to the power minus 2, what should that be? X to the power minus 2 plus 1 over minus 2 plus 1. Alright, so that will be plus x to the power minus 1 over minus 1. So the answer that you will get is e to the power x minus 1 over x. Alright, so that's your answer for the third part. Okay, similarly, the answer for your fourth part, the integration of cos x would be sin x. Not minus sin x, that would be the derivative, plus this would become x cube. Alright, so that's the answer of the fourth part. Okay, so that is how you find the integrations. You can practice some more from your maths books, alright, or maybe some easy basic integrations. That is all you'll be needing in physics. Do not attempt very complex ones. You don't need those in physics. Those will be covered for you in mathematics. Yes, Kushal, well done. Yes, that is the answer. Great. So now hopefully you're getting a hang of this. Great. Okay, so we've already covered this. Let's try some more. Let's try some more problems regarding, okay, this is a derivative problem. Okay, I think the sheet got repeated here. Let's move on. Let's talk about definite integral now. Now, in the past we saw indefinite integral. Let's talk about definite integration. So integration within a specified limit is known as a definite integral. What are the properties of definite integral? So when you're writing this, that integral of fx dx from a to b, you will write this as I of a minus I of b, where I of x is the integration of f of x. So if you did an indefinite integral, alright, okay, one more thing, everywhere I should have written plus c plus c plus c. Don't forget, whenever you're doing indefinite integral, you always write plus c. The quiz will not be on YouTube, it will be on the site menti.com. Yes. Yes. So if you have your integration, indefinite integration of fx as ix, then definite integration becomes ia minus ib. Okay, that is written wrong. It will be ib minus ia. Alright, so it is ib minus ia. First you write what is at the top minus what is at the bottom. Alright. So now similar rules will apply for indefinite integral or definite integral as far as your multiplication with constants is concerned. So if you're trying to find out the definite integral a to b of alpha times fx plus beta times gx, where alpha and beta are constants, then it will be alpha times definite integral of fx plus beta times definite integral of gx. Yes, upper limit minus lower limit, always. Always. Alright. Similarly, you can also break one integration into two parts. Alright, where c would be a number which lies between a and b. Now let's see what I'm trying to say here. Let's just see one thing. Alright. So when I told you guys that the integration is telling you the area under the graph. Yes, Trillions, it is a website. You go to the website. I'll host a quiz there. You can answer, write your answers there. There you'll get the option of selecting your options. All right. Yes, www.menti.com. So let's take a look what I was saying. Yes, so you can select your options 1 to A, B, 3, A, B, C, D. You can also host quizzes there, don't worry. Suppose this was a graph. So what I'm trying to do is, what is fx times dx representing? Let's see. So this is, what I do is, again I'm breaking this graph into very, very small parts. Alright. So if I make a very, very small part of this graph, so this can be roughly approximated as a rectangle. Alright, so what will be the area of this rectangle? I am taking a very small part of the graph. So this is dx. Alright, this length is f of x. Alright, so what is fx times dx? Fx times dx is nothing but the area of this graph. So fx times dx is the area of this small rectangle. Now what happens if I keep on adding all such rectangles? So when you are talking about integration of fx dx from a to b, what you're doing is you're breaking the graph into small rectangles like this. Alright, so let's see. So let's start breaking them into small rectangles. So one is this rectangle, another being this rectangle, and so on. So I'm essentially breaking my graph into very, very small rectangles. So the area of every small rectangle will be written as fx times dx. Then this means summing it up. This is integration. And as I said, to integrate means to sum it up, to put it all together. So when you put all these rectangles together, yes, Kushal, that is the idea. That is the idea. You're taking infinitesimally small rectangles, finding the area of each of the rectangle, and then adding all these up. When you integrate all these small rectangles, which means when you put all these rectangles together, what you'll get is the entire area. This entire area you'll get. Right? So that is the idea behind integration. Alright. I hope you guys followed why this is giving the area. Now imagine, Trillions, I went to IIT Delhi, mechanical from IIT Delhi. Alright. So now, if you have A and if you have B, so integral of this from A to B means the area under the graph between A to B. Now, if you have some other point C in the middle, let's say you have some point C in the middle, so you can always write this as A to C fx dx plus C to B fx dx. Alright. So what is that? That is the area between A and C plus the area between B and C. Alright. That is what you get if you break this into two integrations from A to C and C to B. First you're taking the area between A and C, then you're adding to it the area between C and B. Obviously, when you add these two, it will give you the total area between A and B. Trillions मिल रहा था. I chose IIT Delhi. I was getting IIT Bombay also. I was getting mechanical in all IITs. I was even getting computer science in IIT Guwahati. I was getting computer science in IIT Roorkee. I was getting mechanical in the IITs, in fact. Alright, so I hope the meaning of this is clearer to you guys. I just chose mechanical from IIT Delhi. It's my college you're talking about. Not really. You go to any IIT, it's just full of people like me. So How can I be a legend? There are so many legends then. Okay, let's practice some problems now. Yeah, I know. I know. There was a slide. There is, okay, my net is acting up again. Okay, I don't know. Let me reconnect my net. Alright, it will be better now. Don't worry. I think I've just reconnected my internet. My internet was glitching a bit. It should be fine now. Alright, just hang on for a bit. Alright, let me know if it's better now. Bye bye, Mohammad Farhan. Yes, let's try and find the integrations of these. Alright. Don't worry, it should be fine now. Yes, Kushal, you got that answer right. Plus c, don't forget the c. Yes, the integration of this would be x cube over 3 plus 2x. Very rightly answered, Kushal. Don't forget plus c. Just don't forget plus c. What will be the answer for the second part? How do you get the answer of second part? Yes. Second part is still easier. How about the third part? The second part will also be easy. The second part would be x to the power 4 over 4 minus 1 over x plus 3x square over 2. Of course, plus c. Okay, very nice. So you guys know how to do this one also. Great, well done. Yes, yes, that is correct. No problem, Satyam, no problem at all. Yes, the integration of this would be e to the power 2x over 2 plus 5x plus c. That is correctly answered, Mr. Farhan. Very well done. So here what you do is, because you only know the integration of e to the power x, you have no idea as to what the integration of e to the power 2x should be. So what you do is, you say, let sum u equals 2x. Alright. So now you differentiate this, you know du over dx equals 2. So you can write dx equals du over 2. Alright. Yes, I'm showing it to you, trillions. Okay, let me go over this third one first, and then I'll explain you the second. I will explain the second. Wait for it. So now what I write is, I can write that integration of e to the power u times dx. That is what I'm to find. But I only know integration of u if here there was du. So instead of dx, I substitute this. Alright, so what do I have? I have 1 over 2 integral of e to the power u times du. So this will give me 1 by 2 e to the power u. Alright, that is how I am getting this. That is e to the power u, u being 2x over 2. That is how I am getting the... Yes, I will go over the second one, don't worry. Just let me show you this one first. The second one was very easy, by the way. Okay, let's see if you followed the third one first. Integration of 5 would be 5x, of course. For education, here I'm just taking up the some of the topics which are required in kinematics and which I've used in physics a lot, like some basic trigonometry and some basic calculus. All right, this is going to be very basic. I don't know about what maths sir discusses in basic maths. This is basic maths for physics. Okay, so this is not, this is only basic maths limited to whatever will be used in physics. So did you guys follow the solution for the third one, third part? Yes. Yes, Kushal got it right. Take the power negative and solve it. Exactly, that is how you do the second one. The second one, first part should not be the problem, right? So integration of x cube obviously is x to the power 4 over 4. For this one, you will write this as integration of x to the power minus 2 dx. So integration of this would be x to the power minus 2 plus 1 over minus 2 plus 1. Alright. So that is what I am doing. So that is why I am getting plus x to the power minus 1 over minus 1 plus 3x square over 2. Alright. Yes. I hope that is clear. Great. Alright, let's talk about a few definite integral problems now. Alright, find me the answers of these. Great, trillions. Okay, so let's try this one. No problem. Okay, Niranjan. Yeah, I'm wrapping this up in any case. This is the last problem that I'm discussing. No problem for education. So let's quickly just go over these three problems. These are the last three problems of today. Okay, let's see. The obviously integration would be x to the power 4 over 4. Limits going from 1 to 3. So what will that have? That will give me 3 to the power 4. 3 to the power 4 being 81. Right, yeah. 81 over 4 minus 1 over 4. So yes, 80 over 4, that is correct. The answer is 20. Yes. That is correct, Farhan. Yes, that is also correct. This will be 1 by 2 m v square minus u square. Well done. 1 by 2 m v square minus u square. Yes. Great. No, Kushal, it will be 1 by 4 also. Minus 1 by 4. Don't forget minus 1 by 4. So first you find your integration like this. Then you substitute the upper limit minus the lower limit. Alright, so when you substitute your limits, you'll get 81 by 4 minus 1 by 4. So 81 by 4 minus 1 by 4, that is 80 by 4, which is 20. Yes, that is also very correct. Well done, Farhan. Yes. Yes, both you guys are correct. This will be sine x, limits going from 0 to pi by 4. That will be sine of pi by 4 minus sine of 0, which is 1 over root 2. Alright. So yes, those are the answers for all the three problems. I hope all of you have solved these three. Alright, is it clear? So now you can get some more practice on your own. Go to your maths book, try some of the basic problems. All right, start with these simple problems and stick to that. Just get a hang of this. Objective, easy objective. Some of them may be tricky, but mostly easy objective. I'll try to make it conceptual also. Alright, so if everybody followed all three answers here, so let's move on. So that is it from me today. Alright, that'll be it from my side. Hope you guys learned more than you knew about integration and differentiation. Practice some more and get a hang of this. Thankfully, in physics, you will not be doing too complicated problems related to differentiation and integration. Alright, so should not be a problem. Yes. Vectors, Kushal, vectors. Tomorrow will be a quiz for vectors and we'll start at 4, okay, 4 o'clock. Thank you so much, Farhan. Vectors, hi subject wise. Yes. See you guys at 4 tomorrow. So before I leave, let me remind you about the Unacademy subscription, how you can get it. You can follow easy steps. Install the app, go to the plus section, select IIT JEE as your goal and click on get subscription. Alright. Also, while getting subscription, you can use my code RDLive and get an extra 10% off on already a very affordable and reasonable pricing. Thank you. Vectors, TS trillions, TRS, C trillions, that will be vectors. Vectors. Alright, so if you like today's video, then definitely click on that like button. Also share it with your friends and don't forget to press the bell icon to get notifications of all my future lectures and schedules. Alright, so the PDF of all the slides used in today's lecture will be available to you in the description box. The download link will be available to you by tomorrow. So come back tomorrow and download your PDFs. Yes, do not forget to join us on the Telegram app as well using the link shown there for all the notifications about JEE English channel and the lecture schedules. Yes. Now, before I leave, one more time, my code, referral code is RDLive. Use this code to get your Unacademy subscriptions and also get another 10% off. Alright guys, I'll see you tomorrow at 4 for the Minty quiz from chapter Vectors. Do not forget. Chapter is Vectors. The Minty quiz is tomorrow at 4 o'clock. I'll see you guys there then. Take care. Bye-bye.